Hello. Today I prepared a subject which is classification on a video stream with GPU computing on OpenCL, and this is my 27 2020 update. So it's today. Outside we have beautiful morning in Poland and rainy but really nice, fresh. So let me get started. My PhD subject is detection of objects in the video stream, data stream in real time. My name is Piotr Sowa. My PhD mentor is Dr. Jacek Isidorczyk. I work at Aptiv, and my mentor work on Silesia University of Technology, and we doing together, with basically Dr. Jacek support my PhD. The goal of this work is to prepare artificial intelligence machine learning system to pre-level at least 80% of test car on video log frames. So you can imagine you have test drive that collect data on the video streams, and you want to classify what's on the frames. And the solution I choose is dark convolutional neural network engine, and this engine is famous because of the introduction of the you only look once model, really, and I'm focused on YOLO 2, second version of this, to improve the detect area, to improve the overall process. Now, below you can see how not YOLO model, but how we previously detected from input to classification the objects, right? So you have deep learning in place, and you have the indicator of small place on the picture, some square, and you want to classify this square as a car, truck, or van. That was called RNN. Now the CNN model, convolutional neural model, use convolutional layers. That's because is the name of it, and as you can see, there are sometimes layers of the neural network, and sometimes just computation, like softmax, for example, right? Now, all that started in 2018 with my computer with two NVIDIA GeForce 1080 with the Intel CPU, 64 gigabytes of RAM, and quite strong 1000 watt power supply. And for the first time I was able to run the detection of the image, and when I saw that in 0.1 second the detection was done, and I saw that there are some objects on the predictions detected very fast, I was very impressed, right? And I tried to do some research, understand better, and I want to tell you about my tools for the research. So if you go to kind of school diagram, that you have the PhD dream and the GPU compute power, but also important is to not use too much energy, too much power in power supply. That's power if you save power, and you have very good compute possibility, very fast GPU that consume not too much power. That's important. So I improved in Q1 2019 my rig. I bought two Titan RTX with NVLink. Each card is 3000 dollars. So I assume that will be enough, and I'll be able to do all my PhD stuff on this ring, right? And also I bought the MacBook Pro with the external GPU from Sonnet, which is AMD. And the problem was that on my favorite brand computer, which is from Apple, it doesn't work, right? There was no solution other than CUDA version that I could run on my Mac. And that was basically one of the reasons I want to port CUDA version to the OpenCL version. And all that would be, all that presentation would be about that subject. So I want to check what happened later on in Q3 about 2019 if I leverage two, I think, quite strong and very good Radeon 7 graphic cards, right? I want to check not only one card, but maybe multi-GPU possibility. Also because I started my journey, I bought the calculator or even mathematical computer really to help me with some calculations and improvements. And also this time I finished mostly the OpenCL version, and this adventure was done. I play with the code long time, but really in the last 3 months, last half year between I started, I was able to finish this this work, right? Completely, sometimes redesign, sometimes just port from CUDA to OpenCL. And when I'm telling about redesign, it is that I introduce nice multi GPU model for this, but I will describe you details later on. Now, I thought that this would be not enough, right? So basically, operation system so far was Linux operation system, CentOS and Ubuntu, and yeah, that was the system. Now, my dream was to check also capability of the macOS, and tell you that it ran very well on the ring I'm showing to you right now with the 2 GPUs. And the prototype was the HANNA PC that we call it, with only one AMD graphic cards. But Q1 2020, I discovered that I really need 2 graphic cards on macOS, right? And there is also one thing that I only dream about because of the price, which is Mac Pro, right? Mac Pro is a really amazing device. It could have 4 GPU chips into graphics card because they are dual class of the card, and but the price is about 5 times more than my car is worth. So I wasn't able. It's $25,000 for configuration with the graphic cards for them, and my ring just below on this graph is about $4.5 or $5,000. So it's completely different price. And I'm, as a student of PhD, simply don't have enough money to buy Mac Pro 2019. But I dream big. Who knows what happened later? Now, this machine has i9 processor, 9900K. It has 128 gigabytes of RAM. As I said, 2 Radeon cards, 16 gigabyte HBM2 memory. So I think it's quite strong. I also leverage disk from Western Digital for M2, their black M2, the fastest I could found. And the nice thing about this ring is that it's fully loaded right now. Both cards are used. I'm training YOLO 2 right now, and on the power supply there is a very nice indicator that display actual power consumption. So you see that it's below 300 watts, and this is very important. And I think macOS really respect your hardware. The software that respect your hardware, I would say, because even if I maximally use it, it is quiet. It's not too hot, and Titan RTX, for example, can be 90 Celsius degree, so you can even not touch it. And imagine if you have close computer case that do it, simply you can burn your computer mostly. What I'm doing with RTX from NVIDIA Titan RTX is just I have open case all the time, because simply the cards are too hot and also quite noisy, but that's not the most important issue. So power consumption is very good, and I want to mention mostly that. Now, I also review some single board computers, and I found I check the Raspberry Pi, BeagleBoard AI, Jetson Nano, and BeagleBoard X15, and unfortunately none of them support OpenCL. I think Jetson Nano has potential, but from NVIDIA, but not nice move from NVIDIA. They remove possibility to use OpenCL on it. But there is one very nice device, which is Asus Tinkerboard S. With that, if you buy, you have very nice. You may buy also very nice case with this branding, and its form factors. Cases from the Raspberry Pi fit exactly on the Tinkerboard, and Tinkerboard use the Mali GPU, so you have separated chip, and you can use the you can use OpenCL very efficient, right? My goal was to prepare OpenCL that even on that small RME based CPU single computer unit, I would be able to do some stuff like recognize maybe more from sensors, some patterns, not necessarily from on images, but let me show you more about it in future slides. Now, I also invest in the 2 cameras for my car. My car is Audi A4 2007, so a little bit old, but I put cameras in after windows on the front one and rear one, just after, and you see on the top detection that happen in the front, on the top of detections, and on the below detection you see what can be detected as the post process when I took videos to my computer and run on Linux or Mac OS. You can see 21 frame per second in the corner, and all detected objects, and you see they're very difficult to detect really, because for example back side is difficult. But keep in mind one thing, which is that if you have camera on the back and people see it, and I even used a sticker above the Audi logo on my car that says SJCam, and the people slow down. They give you they don't necessarily want to be on your movie, right? That's this kind of effect I found, and it's quite interesting. Now, my research results, I can show you that the darknet port to OpenCL took 142 change files. As you can see, about 90.5 additional thousands additions, 6.6 thousand deletions. So this is serious work, not the baby work, but I had to read the code a lot, fail about 5 times, and then at last I was able to in short time, with all knowledge about the experimenting with the code, CUDA code with no comments really, and I have to understand really what the code is about, and then port it. And I have already 92 stars. I'm really proud of this number. This is some computation. This is training, right, of the CIFAR10. On the first column, you see the process. So you started with convolutional network forward. So this is, from beginning of the network, you go to the last layer in the network, and convolutional layers basically hold the weights, right? So your knowledge, your model is in convolutional layers. And when you want to teach, sometimes max pool or average pool, I'm sorry, as I said, this is the CIFAR10 process entirely. So you have forward something, backward something, just went through your network 2 times, and then updates on convolutional. That's the process that happened. And you have some numbers in gray first row for CPU, OpenCL CPU, when you use OpenCL for exactly your CPU that you have, and CPU from Intel Iris, and this is on Mac OS processor, right? So you see some numbers, and you can check, just look at what happened, where is the problem. And on the Linux, I check Asus Tinkerboard S with the ARM CPU. I don't remember exact name, so I not put this, but OpenCL was my GPU T760, because my solution shows, when you started, it shows what graphic cards you use or CPU you use. So I know that this is the version of the chip. Now, the first row looks like this on the graph, and I was wonder that there's some information in the news that Apple consider create the ARM based CPU based computers with this CPU, and I don't believe that, right? If you compare OpenCL CPU with relatively small model, which CIFAR10 is 10x10 pixel benchmark really, that you can train and check how and validate how it good is. I don't believe, because it's almost 200 times slower, right? So it need to be very good hardware that not consume power too much, and I think it not happen, but this is just my guess. Now, I have also strong computers, strong GPUs, And here you have comparison in similar way. So on first column, steps in the training, but there is cut of them. There is the portion of them. So there is no forward, backward, and update. It's only portion of the backward computation. And really important is what happened in the convolutional layers. And we choose the moment of time with my mentor that really indicates what happened as a layer, right? For now. Now, this is comparison, and you may see that AMD OpenCL with CL Blast on macOS is not as good as NVIDIA CUDA, but it's almost there. It's not the really slow one. So you may wonder why that happened. Why this strong OS, very good cards from AMD cannot beat the CUDA, and I will explain it in the demo at the end of this presentation if you have enough time. And here, let me remove this. And here you have additional thing. So this one particular layer, we check what's inside. So basically on the different version of the GPU and different version of the software, you need to, for example, in the first row, gradient area kernel. So this is one computation unit on the graphic cards, and then backward BIAS, which is the same because of the engine name. But on the BLAS, on the SGIM, for example, you have different. So at the end you have different names because on different solutions. And the last row is the layer that we combine, but the number is higher because of the overhead. So this is measure higher of the entire layer computation, and you see all the steps. And this is really nice because you see the bottlenecks, right? You see the bottlenecks of OpenCL implementation. And I need to be honest with you that OpenCL or CUDA, it's not the part of the driver. Many people confuse that. Is a part of the extension for operation system, right? So if macOS, as you can see, have very good solution for the OpenCL. OpenCL is implemented beautifully. You can see that beat even CUDA version in computation on all kernels, right? So what is wrong with the OpenCL? Why it's slower? But bear with me. Computation of CUDA YOLO3, graph of the loss that should slowly at the beginning very aggressively and slowly go down during the I think 10,000 steps were done. And on the OpenCL version we have the same but more steps. I mean more time. The time is slower for the OpenCL, and really the question I have, and I know the answer, so I will tell you why it's slower. Now I want to show you some code techniques right now. So I decided to extend CLMEM. CLMEM is basically memory, video RAM, VRAM. And I understand after study some optimization, especially in Intel implementation of the OpenCL, this part, if you have the pointer, which is third from the last element of this abstraction, and this is your RAM, really pointer to your RAM data. you need the pair of the CLMM in the same and exchange only between them, right? That's important to have acceleration. I'm sorry. Okay, and I decide that also pointer to the command Q really because it's not the is the pointer. I think you know C, so I don't want to bother you all details, but also I have a few pointer to the functions, like for example increase, decrease, and add, remove, that type of functions. But I want you to remember CLMM is combined, so VRAM is combined with the RAM as a pair. For now, that would be enough to remember, to understand what I will tell you later on. So first thing, if you have started your OpenCL, which is quite long portion of the code when you start and initiate using OpenCL, and later on the initiate at the end, it's quite long code. Basically, you start a context, you create, check the platform, create a context, create as many queues as GPU you have, and as many kernels really for each later on for computation, and here you have how to make the array, right? In OpenCL, it's not the array, it's making the CLMM, but in this technique you see what I do with my abstraction, right? The buffer is the buff is at the beginning is the abstraction, and I'm making this with the solution, and see on the 29 line. This is technique I have, so it's global OpenCL device ID per thread. The T and then per thread is not the is in thread model in C, and you have only OpenCL queue for each of the memory, right? So you have to understand that for each queue I have separated memory and separated kernel, and that's really unique because CUDA version doesn't have it. And there are a few advantages of that technique I will tell you later. So how to push data, and on line 6 you see that I'm checking if my pointer and what I exactly want to push to the array has the same address, because I'm checking if they're pair, and if so, I'm using the built-in in OpenCL write buffer and Q write buffer function. If not, there's also possibility, so you can map your buffer, transfer with the in 18 lines you have mem copy, and then you unmap the object. Of course, I'm sorry for showing you the code with checking the errors, but to just make it difficult to see. But having errors is also very important. Handling the errors is very important in my opinion. So that's the way it works. Pull from the array. So basically VRAM to RAM, very similar situation. Checking the pointer if they are the same, using the function from OpenCL. If not, map, transfer, and unmap. Now, this is the one of the function that is essence of the having only portion of your CLMM, and I fight with this sometime. So basically, you change the buff org, which is in line 11. You have buff org, and then This is copy of the CLMM that never should be changed. You never should change org because original buffer need to be right there as original CLMM, and you can only copy portion to mem to use the your name of the type .mem, and you have only portion, right? You have only buffer, and that calculation works. I haven't tested on RNN model yet because only that is very old-fashioned. So I focus on the model like CFAR10 for checking and development test, and YOLO 1, 2, 3 for the computation and for my solution. So I need to test it deeply, but I believe that's exactly the way it should be done, right? Now, this is beautiful problem. So you can improve your OpenCL with very nice technique. Please look on the below, and on the third line, tuning number 1. Why we should have 1? If we don't have 1, if we introduce like 16, we expect that our code will be about 16 times faster. If you look on the lines on the top from 7 to 11, 7 to 12, you see what is calculated, and you probably see in line 8 the tuning parameter, right? And in the 10 sums of t parameter. And I really want to explain it to you, but I want to leave it with that to figure it out for a moment, and just look on the code, and we will go through this. So why it cannot be more than 1? Well, in 14 line you have checking if t is 0, which is unnecessary completely and completely wrong. So you should remove this 14 and 21 line, and everything will be smooth and work. Because if you want to even print out the value, you can only use I, the global ID from third line, and T is the local thing, sums in the first line. If you check the parameters, this also local. So there is a very elegant way in the below on the below of this slide, you can see that there is a size of cell int and value is null. You see the value null in 8 line. It's quite long, but I see the null, and if you have this technique, so you put the null, which is tuning multiple size of CL float, you have the solution that has only one parameter to tuning. If you change it, you expect different. At the beginning there was 16 instead of 1 when I figured out, but later I decided that it would be filters divide by 4 to somehow auto tuning, and that works really well on my most important models. Now this is CL Blast patch for the multi-GPU solution that I don't know why, but works only on the Mac OS. I parsed the CL Blast. I put the on my fork of CL Blast. I create a pull request with question and advice how to improve it for other systems, and that's really the problem. In CL Blast is not ready for multi-threading, and it should be. So I changed this portion of the code and a few more. If you go to my fork, Softson CL+, on the GitHub, you should see exactly what was changed. And if you know, please let me know how to improve it on the Linux, for example, because on Linux it doesn't work. You have exception, and I know this because I create my trivial as a gem for multiplication of the matrices, and this trivial one works really well, right? In my model of the separated threads, separated GPU, separated things, it works beautifully. But with CL+ only on macOS so far. And here is, CL+ SGEM function on the 13th line, quite long. As you can see, that's the need, right? That's the need to use CL+. If you don't have it, like for example, or on the ARM, it won't be used. Instead, it will be used by trivial gem. Now, quickly, internet update. This is author of the Joseph Redmond is author of the original CUDA darknet solution. I'm really thank you, Joseph, to create that sophisticated solution. I just follow your structure and improve it in some moment, but there was a very nice journey thanks to this guy. And you may see that about 2 years ago nothing happened. Only README was updated with, from Alexei, and he changed only the README to know everyone, to say to everyone that YOLO4 came to the scene, and this YOLO4 is basically on Alexei fork, but there is only kind of indicator or original darknet. I think Alexei did a lot of work, help on the community, so I think Joseph gave him contributions on this, and he's able to make the commits. Very nice move from Joseph to Alexei. Now, me as a user, I have darknet and Valgrind that works on macOS Mojave, and I have more stars on Valgrind because it really works on Mojave than the same like on High Sierra of macOS. But unfortunately on Catalina it compiles, but there are some issues. And this is really complicated code, really. So I don't know if I'll be able to make it work on Catalina latest version as well. Okay, let's be shorter. So if you look for Piotr Sowa darknet on Google, you see only me on all that links. If you write Piotr Sowa OpenCL as well, you see only me. And quickly stats from 2019 of my personal blog is that on third post and pages rank darknet in OpenCL is detected. And that's really good progress. We will see what happened at the end of 2020. My competitors, right? This is important. I'm not competing with anyone, but if you were right some time ago, darknet OpenCL, the first one and the second one, I think, came from the two different fork, two different solution, even on GitHub. And I try to compare them. So the first competitor, second, and me at the end. I want to be honest that YOLO first training not work anymore, right? When I adopt all changes, training stopped working because there is something that breaks the compatibility really with the max pool. There is a different calculation, and you cannot use anymore. But you can, you are able to test it or play with it if you have already weights that work. Now, to remind you, and which will be, I'm sorry for a little joke with the logo, but I changed the darknet to the lightnet, and I hope that Joseph take it as a joke and not really as a profound. His very nice logo type. And for implementation, this solution, we could have beautiful and very strong NVIDIA DGX2. I don't know price for particular company, but the price I found in some news was $400,000, right? Or maybe also for the implementation, I could use at work MacBook Pro, but to be honest, $25,000, especially in that situation we have right now, would be very difficult to ask at work. So it's only dream. I'm sorry for a moment. Now, I think that this solution of 80% at least, and I expect even 99% of accuracy, should be how to eat the elephant, piece by piece, right? Everyone knows that. So let's get one frame of the virtual log, copy them to 4 GPUs, with 4 queues in OpenCL, with 4 separated compiled kernels for each, and we may detect on one GPU, it can be YOLO 2 model with the VOC, another with the Coco, another with Nuisance, another with the whatever set of images you have, and then when you forward this information, you just want to combine, maybe with OpenCV, Open Computer Vision library, you can combine, because if they are very close to each other, you can combine, oh, this is one object. If they are completely on the one model detected and on they're not, you leave the what is not. Usually detection need to be checked by the human, but I imagine that delete only what is unnecessary is the way easier to detect, to make the detections than mark manually. I'm sorry for the gravelly voice, but I have probably cough starting, and we try very hard. For me it's very difficult, for my mentor not necessarily. We work on the publication together on the overleaf, which is a tool for making the publication. We try in one magazine, however they refuse it, but with many reasons, and I'm improving right now, waiting for approval for my mentor, and if we try in different magazine, but I don't want to tell name of where we try, to not make them unhappy. This is few references, and some of them, like second one or fifth one or 20, is from my blog. I'm sorry to say, but I think I can 20 especially. I don't want to promote myself, but I know that some people in master thesis or PhD thesis citate links from my blog. right? So why not having this in the references? And now I promised you to demo on HANNA PC. So there we took already quite long time, but I can show you two things very quickly. There is a very good program. It's called Beyond Compare. Here you have CUDA version. Here you have OpenCL version. And one of the a bit secret improvements you may check in the data C right there. And this is you know, if there will be end of line in the file name you marked, sorry, in your file name that is open, it removes that. Right? That's trivial thing, right? But here is very nice one, which is only unique. So it's really you get a lot of images. You took the random portion and you train the network, and that stay. But in the small, you know, with the small subset, you need to have unique randoms. Why you can random 10 the same images, and not necessarily want to train a network to just focus on those 10 in one step. I know this might be very little improvement, but I make sure that in subset you have only random unique images to train, right? That was one thing I want to show you, and I can even advertise this tool. Is great. It's especially rule based. When you have code in C and someone put two spaces and normally is detected as a change, if you rule based, it understands the C and eliminate what is only a white space change or wherever. It's a great tool, and I'm using Cilion. So at the end, quick demo. So let me reload CMake when you started. This is all default parameters, and then I can show you how CFAR is trained. And to be honest with you, I spent 1 year for playing with this code to have CFAR that works. And you know what? It works on the 2 GPUs right now. So let me very quickly open the activity monitor. If you go on the GPUs, you have 2 of them, and okay, right? And you see that darknet here. You need to refresh, so give it a moment. Use 78%, 75% of the GPUs. So that's the proof that the darknet is very efficient to use the GPUs, right? My port. Now, darknet use only, I mean, it uses CPU times to synchronize the networks, so it's useful. However, if you train big model like YOLO 2, YOLO 3, then the CPU usage is minimal because most of the work is done by GPU, and synchronization of the thread is not necessary. The memory we have, system memory, I have, as mentioned, a lot of them, but to not worry about. Energy you can check also, but I don't want to give you lesson of activity monitor. Just wanted to show you that both GPUs are leveraged. Right now, let me close this, and I tell you that I will explain to you why there is why CUDA is slower, right? So I have several benchmarks. So let me find YOLO 2. There will be CUDA train benchmark, and then OpenCL train benchmark. So there are logs for both benchmarks. Benchmark is the one step with logging of every steps as possible, as detailed as possible measure. And at the just after create the network, right? So I have explanation what the card was used, and see what happened with the memory transfer on the same box, on the same operation system. And I want to remind you, Titan RTX is the GPU. What happened with memory transfer and why? Why on Titan, when you use CUDA version and OpenCL version, the OpenCL has degraded transfer memory from video RAM to RAM to system memory? I don't know, but that's the reason OpenCL is slower, right? So that was promised, and I told you. Now I want to show you why and where to look to understand the CFAR training, if it's good or not. So it takes 5,000 steps. We started with about 2.3 loss, right, in the step. Loss is the error of the, loss is the English term. You need to check what does it mean. So loss and average loss need to slowly go down, right? At the beginning of YOLO 2, for example, it's go down and then slowly because of the rate. What is rate? It's a learning rate that, as you can see, is slowing down easily, almost linear. I think linear. And then seconds and how many images. This number is not how many images you have, it's how many images you show the network so far to learn. This is your mark, this is your frame, how many you have, right? And this is only that. Now let me go back to my presentation. And that was the classification video stream with GPU computing on OpenCL, May 27, 2020 update. And also, yesterday was a very special day, the Mother's Day, and probably you saw my popular video from 2018 from 26th of the May, which is in Poland, Mother's Day, and I wish my mom everything and health, really good health. But unfortunately, she passed away, 1st January 2019, and I believe strongly she is in better place right now, and all that work I want to dedicate for her in my PhD thesis. That's the reason. Thank you so much for listening, for having chance to listen what I'm recording, and thank you.